Hi and welcome back. Tonight's notes, we're going to be starting Unit 11. And Unit 11 is volume and surface area, I believe. Let me just pull it out really quick to double check. That's what it's called. Oh, sorry, solids. And this is page 69. So Unit 11, solids. And our first notes are actually going to be a review. And it's going to be a review on areas of polygons. So we've done this before. But for this unit, we really need to for sure know how to find the area of polygons. So I just want to review it. And this is going to be on page 70. So we're going to find the area of different polygons. Okay. The first polygon we'll find is the area of a right triangle. Okay, so area of a right triangle, and it could look like this. Okay, and we would need to find the area of that. Now, we know the area of a triangle, or a right triangle, excuse me, is base times height divided by 2. Okay, now in this case, the 5 is our base. And the height is right here. This is our h, which we don't know. We need to find that. Now to find that, we use Pythagorean theorem. So I'm going to do that off to the side. That would be h squared plus 5 squared equals 13 squared. So when you solve that out, what do you get for h? You should have gotten 12. Okay. So then that's our h. So when we plug that in, we'll get the area is going to be 5 times 12 divided by 2, which means the area is 30. Okay. So that's finding the area of a right triangle. Okay. Now let's find the area of an equilateral triangle. Okay, so that's going to be my equilateral triangle. I have a side length of 6, and that means 6 is on every side length because they're all equilateral. Okay, and the area stays the same for triangles. It's still base times height divided by 2. And in this case, 6 is the base. And the height you have to draw in. That's the height of that triangle, okay? Which we don't know, okay? To find that, there's a couple ways you can do it, okay? Well, knowing that it's an equilateral triangle, you know the degrees. If the whole triangle is 180 and you divide it by 3, you're going to get 60 degrees for each angle. So it's 60 degrees, and this one would be cut into 2, so that's 30 and 30. Okay. Now there's 2 ways to find that height. You can use your properties of special right triangles, the 30, 60, 90 triangle, or use trig. Okay, either one is okay. I'm going to go ahead and use trig to find this, okay? So when we do this, this cuts it in half, so we have 3 and 3. And I'm going to find the tangent of 60, which is going to be opposite h over 3. Tangent of 60 is opposite over 3. So that means our height, when we cross multiply, that'll be 3 times tangent of 60, 5.20. That's our height. Okay, so now we can plug that in. Area is 6 times 5.20 divided by 2. And when you put that in your calculator, 15.59 is going to be our area. All right? So the trick here is to remember that you need to use trig to get those values. All right, and then the last example we're going to do is the area of a hexagon. And I know we've done this a lot of times, so I'm actually going to have you try it before I go over it, okay? So let's draw our hexagon. And I should have written regular right here, so I'm going to go ahead and write that in. Okay, regular means that all sides are the same. And we're going to have a side length of 8. Okay, so go ahead, find the area of that hexagon, or do your best, insert in your answer, and then I'm going to go over it after. Okay, so the first thing you should do is you should draw that triangle. And then I'm going to blow it up. So what that means is I'm going to draw it really big so I can work inside of that triangle. Okay. And I always like to write down how many triangles there are. Well, if I continue making those triangles, how many triangles will there be? There'll be 6. So I'm going to write down here 6 triangles. And the reason I'm going to do that is so that I remember by that 6 at the very end. So I have this triangle. Now I'm going to find my central angle. By doing 360 divided by 6, or the number of sides, and I get 60. And then when I drop that height down, it cuts it in half, so we have a 30 degree and a 30 degree. Okay? This also cuts in half, so we have 4 and 4. Now we still need to find our height. And again, we can use trig or we can use our special right triangle. I'm going to go ahead and use trig this time. So given this 30, this will be the tangent of 30 equals 4 over h, opposite over adjacent. And when you solve this, this will be h times the tangent of 30 equals 4. Divide by the tangent of 30. Divide by the tangent of 30. And we get h equals, and let's put that in our calculator, 6.93. So that's our height. So now to find the area of this triangle, and I like to designate that I'm finding the area of the triangle by drawing a little triangle. Again, it's base times height divided by 2. So that's going to be base is 8, height is 6.93, divide by 2. So we get 27.71. Now, what do I have to do with that 27.71 to finish up this problem? You're going to have to multiply it by 6 because of those 6 triangles. So I'm going to draw an arrow and write multiply by number of triangles. Just so you remember, that's what we're doing. So I'm going to do 27.71 times 6, and I get 166.28 as my final answer for the area of that hexagon. Okay, so like I said, this was just a review to give you some ideas of how to find the area of some polygons, which you will need for this unit. Okay, all right, for watching.